Hello, everybody. This is John Ross, and I'm here to walk you through how we can translate a number from its standard form into its expanded form. Our learning objective for our mini lesson today reads as I can read and write large numbers through 999,999,999 in expanded form. For our activator, we have a rectangle that has several pieces of mathematical language located within it. I would like it if you would take about 20 seconds to analyze those pieces of information within that rectangle, and while you do so, look for any connections that you can make between the pieces of information. Are there any similarities? Are there any differences? And your 20 seconds begins now. All right, our 20 seconds has come to a close. I hope you made some good observations and made some good connections. And I will now share some of the connections that I made between the pieces of information found within the rectangle. I first want to note that we have a number here that is written in its standard form. Then we have a number here that is represented in its model form. We have a number here written in its expanded form, and finally we have a number here written in its word form. And hopefully you were able to kind of see that, well, all these numbers have a little something in common, and that's that they all involve one within their respective places, such as the ones place, the tens place, the hundreds place, and the thousands place. Whether we are representing that number in its standard form or in its model form, with one unit, one rod, one flat, one cube, in its expanded form, where we note the value of the one here as 1,000, the value of this one as 100, the value of this one as 10, and the value of this one as 1. Or whether we write it in its word form. They are all the same number, just written in multiple forms. And so I just find that to be pretty fascinating in its own right. Here, we are going to decompose a number and really break it down and analyze it part by part. So we have a place value mat, and we are going to strip this number and place the digits in the appropriate columns. So this 5 is should go in the hundreds column. This 5 should go in the tens column, and this 5 should go in the ones column. Now, if I were to want to represent that number, which is 555, in its model form, I could place on this place value mat 5 flats. And if I wanted to place this 5, which is in the tens place, I could place 5 rods in this space. And then for my 5 ones, I could place 5 units. For our value of the digit, we have 5 flats, which we know each flat has a value of 100. So if I have 5 of those hundreds, that means that this digit has a value of 500. And this digit, which is in the tens place, can be represented using 5 rods, and each rod it has a value of 10. So if I have 5 groups of 10, I have a value of 50. And then here I have 5 in the ones column, which is represented with 5 units. And those 5 units have a value of 5. Now, if I wanted to, I could place a plus sign between the 500 and the 50 and the 50 and 5. And when I do that, I have successfully translated my number from its standard form into its expanded form. For 666, I can again decompose that number, break it down, and first I want to note that the digit in the hundreds place is a 6. The digit in the tens place is a 6. The digit in the ones place is a 6. And if I wanted to take that number and translate it from its standard form into its model form, since I have a 6 in the hundreds place, I would need 6 flats. And because I have 6 in the tens place, I would need 6 rods. And because I have a 6 in the ones place, I would need 6 units. And now, to represent the value of each digit, I can note that we have a 6 in the hundreds place, and that can be represented using 6 flats. And each flat is worth 100, so that's 6 hundredths. So that means that the value of our 6 here is 600. The value of this 6, which is in the tens place, is 60 because we have 6 10 rods, and each rod has a value of 10. And then we have 6 units, and if I have 6 units in my ones place, that means that the ones place has a value of 6. And again, if I wanted to, I could place a plus sign between my 660 and my 60 and my 6, and by doing so, I end up getting my number written in its expanded form. So there we have successfully translated the number 666 into its model, but also its expanded form. Here we have a multi-digit whole number. And the first thing that I note is that it spans one full period and moves into a second period. This first period is the ones period. Then we have a comma, and this next period is the thousands period. So I know that this 4 is in the 10,000s place. So if I have 4 10,000s, then that means that I have 40,000. If I have a 3 in my thousands place, that means I have 3,000s, which remember can be represented as 3 cubes. And so those 3 cubes have a value of 3,000. I do not have to represent the digit in the hundreds place because that digit actually has no value. So I can skip over that and move to the tens place. And so for the 3, I can note that it is in the tens place, and so therefore it has a value of 30. And finally, for the 8, it is in the ones place, so it has a value of 8. So here we have, again, successfully translated 43,038 into its expanded form, which reads as 40,000 plus 3,000 plus 30 plus 8. And for our next I do, we have a number that spans 2 full periods and into a third. And so again, this is my ones period, this is my thousands period, and now I've moved into my millions period. And so I know that that 6 is in the millions place, and so that 6 can be used to represent the value of 6 million. And I move on into my thousands period, and that 3 is in the 100,000s place. So if I have 300,000s, that means that that 3 represents the value of 300,000. Because In the 10,000s place, in the thousands place, I do not have a digit of value. I can skip past them and move to my 5, which is in the hundreds place, because clearly that hundreds place does have a digit of value. And so that 5 can be noted as having a value of 500. I can skip over the digit in the tens place because that digit 0 does not hold value. And I can move on to the ones place, which has a 4, and that 4 has a value of 4. And so here we have represented a 7-digit number in its expanded form, which reads as 6,000,000 plus 300,000 plus 500 plus 4. And then we have a 5-digit number which spans one full period and into a second period. And so I have 0 in the ones place, 8 in the tens place, 7 in the hundreds place, 0 in the thousands place, and 5 in the 10,000s place. So that 5 10,000s can be represented using 50,000. The thousands place does not have a digit of value, so I can skip over that and move into the hundreds place, and that is a 7 in the hundreds place. So that 7 represents a value of 700. Then I can move into the tens place, and that digit 8 has a value of 80. And my digit in the ones place does not hold value, so I do not need to note it. So 50,780 written in its expanded form is 50,000 plus 700 plus 80. And next we have a digit that moves across into 3 periods. So we have our ones period, we have our thousands period, and we have our millions period. That 3 represents 3,000,000. I do not need to represent my digit in the 100,000s because it does not hold value. The 4 is found in the 10,000s place, and so it has a value of 40,000. The 5 is found in the thousands place, so it holds a value of 5,000. And the 9 is found in the hundreds place, so it holds a value of 900. And I don't have a digit of value in the tens or the ones place, so I don't need to represent those. So the number 3,045,900 can be translated into expanded form and written as 3,000,000 plus 40,000 plus 5,000 plus 90. And that is the number in its expanded form. So now we have one last one, which reads as 490,005,037. So it's spanning 3 periods, our ones, our thousands, and our millions. This 4 is in the 100 millions place, so that means that it has a value of 400 million. This 9 is in the 10 millions place, so that means it holds a value of 90 million. And then we have a string of 3 zeros, and of course zeros are simply placeholders where they note and communicate to us that there is not a digit of value in this case, the millions place, the thousands place, the 10,000s place, and then even the hundreds place. So I can skip from my 10 millions all the way to my thousands. And I note that the digit in the thousands place is a 5, so that 5 can be represented as 5,000. Again, I can skip that hundreds place and move into my tens place, which has a 3, and so that 3 can be represented as 30. And finally, 7 in the ones place, and that 7 ones can be represented as 7. So here we have 490,005,037 written as 400 million plus 90 million plus 5,000 plus 30 plus 7. And so at this time, I'm going to invite you to go ahead and move into your independent practice, which is found in Schoology.